We're going to look now at some more tools for solving for unknown values in a right triangle, and these are called the trigonometric or trig ratios. And we can use these when we have specifically a right triangle. Remember that when we're labeling a right triangle, for example here, if this is triangle ABC, across from the right angle, we always call that side the hypotenuse, and we can identify opposite and adjacent sides as well, as long as we're talking about looking from a specific angle. So here, if we're looking from angle A, across from that is the opposite side, and beside that is the adjacent side. And these labels will become really important when we're using the trig ratios. The trig ratios have different names. There are 3 of them that we'll be using: the sine, cosine, and tangent ratio. And remember that a ratio is just a comparison, and in this case we write it as a fraction. And with the trig ratios, we're looking at a fraction or comparison of 2 sides in the right triangle. This ratio remains the same for a given angle. So this gives us 3 numbers in a trig ratio, 1 angle and 2 sides. And as long as we know 2 of those values, we can always calculate the third. First, we'll look at how to solve for an unknown side. Each of the 3 trig ratios, remember, represents a different pair of sides from the right triangle. For example, the sine ratio, sine of angle A, remember those capital letters represent angles, is equal to the ratio of the opposite side over the hypotenuse. The cosine of an angle A looks at the comparison of the adjacent side to the hypotenuse, and the tangent of angle A is equal to the ratio of the opposite side over the adjacent side. So the trig ratio we use for any specific problem is just based on which sides or angles we know. This acronym here can help you remember the trig ratios. Sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent side. You may have heard this before as SOHCAHTOA. Let's look at an example, and you'll definitely want to get your calculator out and make sure you know how to use it for these problems. Looking at the first question, we want to find the dimension of the missing side, or side x. Our first step is to label the hypotenuse, opposite, and adjacent sides, and we're going to label them based on the angle that we know. So we know this angle is 27 degrees. We can call it angle A for reference, which means the side across from that is my opposite side. The side across from my 90 degree is always my hypotenuse. And the side next to angle A is then my adjacent side. Next, I'll look at the side that I know and the side that I want to find to choose which of the 3 trig ratios to use. I know the value for my adjacent side, and I want to find my opposite side. The only trig ratio with both opposite and adjacent side in it is the tan ratio, so for this question, that's the one I'll use. I'll write that out. Tangent of angle A is equal to the opposite side over the adjacent side. Remembering that there are 3 measured values in here, my angle and 2 sides. So now I'm going to substitute in the values that I know. So the tangent of angle A is 27 degrees, is equal to the opposite side, which I don't know, so I'll just record that as an x, my unknown, over the adjacent side has a measurement of 10. Finally, I need to do some algebra to rearrange this and isolate my unknown x, and then I can punch this into my calculator. To get x by itself, right now it's being divided by 10, so on the other side of the equals or the equation, I do the opposite operation. It becomes 10 multiplied by the tangent of 27 degrees. Tan of 27 degrees is something we can punch into our calculator. It will give us a number, and we can multiply that by 10. Quite often you'll see that we write the number we're multiplying by first, and that's often how you'll need to punch this into your calculator. Once we do this, we'll find out the value for our unknown side. So take a look at your calculator and make sure you're in degree mode. At the top of your screen, you should see a DEG, or possibly just a D depending on your calculator, and this tells your calculator you're putting in angles in degrees. You may need to toggle that with this DRG button if you are in radians or gradians. Once you've made sure you're in degree mode, we can punch this into our calculator. 10 times, find your tan button and press that, and then just put the angle, 27. Press equals, we get 5.095, or to one decimal place, we know that side x is 5.1. We're not given any specific units here, so I don't have any units in my final answer. Let's work through a couple more examples so that you can practice setting these up and punching them into your calculator. Again, we'll find the missing side and round to one decimal place. Here, our missing side is labeled with x again, and we'll label our triangle first. We know this angle, again, we can call it A for reference, is 46 degrees, and I can label my triangle. This is my opposite side. Across from the 90 degree is the hypotenuse, and that's the side I'm trying to find this time. And beside angle A is my adjacent side. I'm going to look at what I know and what I'm trying to find out. I know the measurement for my opposite side, and I'm trying to find the hypotenuse. If you remember that acronym, SOHCAHTOA, the trig ratio that has both hypotenuse and opposite is the sine ratio. So sine of angle A is the opposite side over the hypotenuse. Once you've chosen your ratio, you can sub in what you know. Sine of angle A is 46 degrees equals the opposite side has a measurement of 8 divided by my unknown hypotenuse x. Now you need to rearrange your equation. If you're comfortable with the rearrangement, you may do this in one step. I'll show it in detail. First, to get rid of the fraction, I'm going to multiply by this x. So on the other side, this becomes x times the sine of 46 degrees equals 8. I've gotten rid of the fraction, but I still have to get x by itself. To do so, I need to move this sine 46 to the other side. I'll do the opposite operation. It's being multiplied right now, so on the other side it'll be a division. So x equals 8 over the sine of 46 degrees. As you get comfortable with these questions, you may simplify the steps in this rearrangement and get right to there. Once we're here, the x is by itself, so we can put this into our calculator. Again, making sure you're in degree mode, we do 8 divided by sine 46 equals 11.1213, or to one decimal place, the hypotenuse is 11.1. Remember, you can always check your hypotenuse will always be your longest side. Let's do one more example. We're given a practical problem, so we'll read through it and start with a sketch. We have a ramp that has an incline angle of 8 degrees. The ramp has a run of 4 feet, and we want to find out its rise. So if we picture a ramp, the run, remember, is the horizontal distance, and the rise is the vertical. Those will meet at a 90-degree angle. The run here is 4 feet. We want to find the rise, that's our unknown, I'll label it x. And I know the incline angle, or angle here, is 8 degrees. Now that we have a triangle set up, we'll go back to the same steps as the previous problems. I'll label based on the angle that I know. The hypotenuse is always across from the 90 degree. Across from the angle that I know is the opposite side, the rise in this case, and beside angle A is the run, or the adjacent side. Looking at what I know and what I'm trying to find out, I know the value for my adjacent side, and I want to find the opposite side. From my options for the trig ratios from SOHCAHTOA, the only option that has opposite and adjacent in it is the tan ratio, so that's the one I'll use. Tan of angle A is equal to the opposite side over the adjacent side. Subbing in the values, tan of 8 degrees is equal to the opposite side is x, the side I don't know, and the adjacent side is 4 feet. To get x by itself, I'll need to move this divide by 4 to the other side, so it will become multiplied by 4. So you can write it with the x on the left if you prefer. 4 times tan of 8 degrees. Notice you often won't see a multiplication sign there. If you like, you can add it in. And then you can go to your calculator. 4 times tan of 8 degrees is equal to 0.562, or to 1 decimal place, the rise is 0.6 feet. In the next video, we'll see how to use these trig ratios to solve for unknown angles as well. Make sure you've practiced these with your calculator so that you know you're punching things in correctly first.